In this video, we are going to look at a related rates example. So we are going to jump right in. Here we have oil spills out of a tanker at a rate of 90 gallons per minute. The oil spreads out in a circle with thickness of 1/8 of an inch. Determine the rate at which the radius of the spill is increasing when the radius reaches 100 feet. All right, so this problem, it's a little bit trickier. We have 90 gallons per minute. That is a volume, right? So gallons is a volume. So this is telling us the change in volume, dV dt, with respect to time, is 90 gallons per minute. And we know that there is some relationship to the thickness of the circle. We have the radius is in feet and inches. So let's rewrite the volume. Let's rewrite it in terms of cubic feet. So 90 gallons per minute would be about 12 cubic feet per minute. So that's a conversion that I would look up. So how many cubic feet is 1 gallon? And so then you can convert from gallons to cubic feet. And that's what we've done. Let's draw a picture of the setting. So we have this oil that's spreading out. The thickness is 1/8 of an inch. We have some radius r. And our volume then is, so the volume of a cylinder, right, so this is a cylinder, is going to be pi r squared h. Now, is that value h, is that changing? Well, this problem tells us the oil spreads out in a circle with thickness of 1/8 of an inch. So this is telling us that that thickness is going to stay the same as it continues to spread out. So it's pushing it out at a constant thickness. So we can plug in our 1/8. Well, we can almost plug in our 1/8. We can't quite just plug in 1/8 because this is in inches, but our volume we have in cubic feet. We're going to think about radius in feet. So we need to rewrite this thickness in terms of feet as well. So that value of h is 1/8 inch. In feet, that would be 1/96 of a foot. So our volume is pi over 96 times the radius squared. Great. So now, what are we going to do with this? Now we're going to take the derivative of both sides with respect to time. dV dt is equal to pi over 48 r dr dt. It became pi over 48. We brought the 2 down from the r. 2 over 96 is 1/48. And now we have that derivative. Now we're going to plug in the known values. So what is dV dt? Well, dV dt we found up above, or identified up above, was 12 cubic feet per minute. So we'll replace dV dt with 12. I should have observed or noted, is that value of 12, is that going to be a positive 12 or a negative? So is the volume increasing or decreasing? Well, it's spilling out of the tanker, but we're thinking about the spread of the oil. And so that volume of the oil that's outside of the container is increasing. It's getting larger. So it's positive 12. our rate our radius is 100. And we want to figure out what is dr dt. And so then solving that for dr dt, we have dr dt is 12 times 48 over 100 pi, which is approximately 1.833. And what are the units that we are going to have here? So our volume we had in cubic feet. Our radius is in feet, so this is in feet per, and our unit of time, this was per minute, so we are thinking per minute. So that is the rate of change in the radius per unit of time. And that is how quickly that radius is increasing. All right. We will see you in our next video where we do yet another example.